This is a key to topic 17, part A, worksheet 2. And in number 1, it says a relation is symmetric about the y-axis, and if a point negative 3, 4 is on the graph, then what other point must be on the graph? So when doing this kind of problem, it's always helpful to have a coordinate plane in front of you. So for example, in number 1, you're told that the point negative 3, 4 is on the graph. So let's go ahead and plot that point negative 3, 4. So negative 3, 4 is here. All right, so there's negative 3, 4. So I'm going to go ahead and label this negative 3, 4. And you're told that this graph, whatever this graph is, you're told that it is symmetric about the y-axis. So that means that if it is symmetric about the y-axis, then the distance from the y-axis from this point should be the same on this side as well. So if you notice, this distance here is 1, 2, 3 units from the y-axis. So this other point should be 3 units from the y-axis as well. So 1, 2, 3. So there's that other point. And so the other point then would be 3, positive 4. So 3, positive 4. So that's the answer to number 1. So 3, 4. Now, just to remind you, if you don't have access to grid paper like this, just do something like this. So, for example, um, so you just do a coordinate plane yourself. So do something like this. So this number 1. So remember, you're told that the point negative 3, 4, 1, 2, 3, 1, 2, 3, 4 is on the graph. And so if this graph is symmetric about the y-axis, then this point here, that distance should be the same as that distance. So that distance is 3 units to the left, so this distance will be 3 units to the right. And so that's all you do. So you don't need something like this where all these numbers and grid lines are there. You can just do your own. All right, so this would be the point 3, 4. Okay? And then you could do the same thing with the other one. So with the other one, number 2, you're told that a relation is symmetric about the x-axis this time. And so if the point 2, 5 is on the graph, then what other point should be on the graph? Now this time you're told it's symmetric about the x-axis. So let's just do one like we did this one. So if symmetric about the x-axis, and you're told that this point is the point 2, 5 is on the graph. So 1, 2, 1, 2, 3, 4, 5. All right, and remember, symmetric about the y-axis. All right, so that distance should be the same as that distance here. So the distance from the x-axis is 5 units. See that? 1, 2, 3, 4, 5. So that's the point 2, 5. So that distance is 5 units, and so you got to go 5 units down as well from here. So 1, 2, 3, 4, 5. And so there's the other point, and so that would be the point 2, negative 5. Okay? So 2, negative 5 goes here. And then you do the same thing for the other one. So a relation is symmetric about the origin. So this sum is symmetric about the origin. So if the point 4, negative 6 is on the graph, then what other point should be on the graph? So again, do something like this. So you have that this point is 4, negative 6. So 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, negative 6. All right, is on the graph. It is symmetrical about the origin. So you got to think, if it's symmetrical about the origin, then this distance should be the same as that distance. All right, so notice though it's a diagonal, so you got to just approximate this. But think, so if this is the point 4, negative 6, then this point here, see how this is 4 units to the right here, that's 4 units to the right of the y-axis, and this should be 4 units to the left, right? So 1, 2, 3, 4. And then you see how this is 6 units down from the x-axis, then this should be 6 units up. 1, 2, 3, 4, 5, 6. All right, and so that should be the point negative 4, 6. All right, so negative 4, 6. So that distance, same as that distance. And basically what happens is that the if this is your point, then the coordinates of both the x and the y are opposites here. So if this is 4, this is -4. If this is -6, this is +6. All right, so that'll be the point -4, +6. All right, now using this idea, you can use this idea that we just did, the way we got these, with these as well. So, for example, so let me go ahead and use another sheet of paper. So you're told that a relation is symmetric about the uh, x-axis. So relation has x-axis symmetry. So if you replace, so this is test for symmetry. So a relation has x-axis symmetry if you replace y with, and then you got to fill in this blank. So remember, you're dealing with x-axis symmetry, right? That's what this says, x-axis symmetry. So if you have a point here, and this is the point xy, and then it's x-axis symmetry. So this point here would be the x-coordinate stays the same, the y-coordinates are opposites. So basically they're saying you're going to replace y with -y. So that's what this says, y with -y. All right, so if you can't remember, and don't memorize this, you use pictures to help you, use diagrams, coordinate planes, use concepts to help you to understand what goes in these blanks. So for example, in part B, a relation has y-axis symmetry. So if a relation has y-axis symmetry, so if you're told this is y-axis symmetry, so let's say you have this point here, xy, then if it's y-axis symmetry, then this point should be on the graph as well for y-axis symmetry. And so if you have y-axis symmetry, then notice that the y-coordinate stays the same, but the x become opposite. So this is -x, y. So in this case, you replace x with -x. So replace x with -x. And so for the origin, I want to show you what's happening. So if this, let's use this point here. If this is the point xy, and you have origin symmetry, then this distance is going to be the same as that distance. And so notice that the coordinates here will be -x, -y. So basically you replace x with -x and then y with -y. So for origin symmetry, you're going to replace x with -x and y with -y. Okay? All right, now let's go ahead and go to number 5. Now number 5 makes you understand how to do this algebraically. They're not asking you to look at the graph. They're asking you to determine algebraically. So don't draw the graph of this and think that's all you need. You always must read the directions. The direction says determine algebraically if y equal x squared plus 4 is symmetric to the x-axis. So there's an A part, there's a B part, and there's a C part. So you must do each of those parts because that's what it says. So it says determine if symmetric to the x-axis, determine if symmetric to the y-axis, determine if symmetric to the origin. Okay? So in part A, so let me go ahead and do that here. So part A, so we want to see if symmetric with the x-axis. So x-axis symmetry. All right, now remember the function we're using is this, y equal x squared plus 4. So for x-axis symmetry, remember for x-axis symmetry, we replace y with -y. And if it yields the original equation, then our relation, then our function is symmetric about the x-axis. Our relation, rather, symmetric about the x-axis. So you replace for x-axis symmetry, x-axis symmetry, replace y with -y. So that's this right here. So we get y. I'm going to replace. So remember, replace y with -y. So I get -y equals, now remember that's all it says you do, so leave everything else the same, x squared plus 4. Now once you do that, there's nothing else you can do here, so now what you want to do is compare. So now you want to compare -y equal x squared plus 4 with y equal x squared plus 4. All right, and then compare those two. Are those two exactly the same? Well, no, because the right side is the same, but the left side's not. So those two equations are different. All right. So so the answer is they are not the same. Well, you're going to say they are not the same equation. Now what that means is this. So this means that y equal x squared plus 4 is not symmetric about the x-axis. Okay, so that's what that means. All right, 5b. This time you want to determine if it's symmetric about the y-axis. So this is y-axis symmetry. So I remember we're looking at y equal x squared plus 4. So I want to know, does algebraically, does this relation have y-axis symmetry? Is this relation symmetric about the y-axis? So remember, the direction says algebraically. Don't look at the graph, algebraically. So algebraically, to determine y-axis symmetry, we replace x with negative x. So replace x with negative x. All right, now when I do that this time, I get y equal, remember replacing x with negative x, but that's in parentheses, so negative x squared plus 4. Now you got to simplify this. See here, there wasn't anything to simplify because negative y stays negative y. But you know that negative x squared, you can rewrite that. You know, you have enough knowledge to know that negative x squared means negative x times negative x, which is a positive x squared. So this becomes y equal x squared plus 4. And now, see, now compare that with this. So this is the same as this. So notice you're going to say this. You're going to say, okay, now remember we're comparing y equal negative x squared plus 4. So you're going to, with y equal x squared plus 4. So you're going to say this. You're going to say, well, this is y equal x squared plus 4. These are the same, right? Same. So therefore, so this means that, remember this is our relation right here, y equal x squared plus 4 has y-axis symmetry. That's what that means. Okay? All right, and then C, so let's look at C. So in C, all right, in C, you want to look at origin. All right, so the question is, does y equal, does y equal x squared plus 4, does that have origin symmetry? Well, with origin, remember you replace both variables. So replace x with negative x and y with negative y. Negative y, okay? And you got to show this, so you must show that. So y becomes negative y, x becomes negative x, and then you're squaring that plus 4. Now simplify this. This becomes negative y equal, negative y stays negative y, negative x squared we saw becomes x squared plus 4. Now compare negative y equal x squared plus 4 with the original y equal x squared plus 4. And are those the same? No, they're not the same. The right sides are the same, but the left sides are not. So these are not equal. So this means that y equal x squared plus 4 does not have origin symmetry. All right. So the only symmetry it had was y-axis symmetry. That's the only symmetry it had. All right. So that's how you do this algebraically. So if it says algebraically, this is what you got to go through. This is what you have to go through. So that's going to take care of the key to topic 17, part 8, worksheet 2.